Shalom to you. In this video, let us evaluate a couple of trig functions using cofunction and even odd identities. So you just need to remember that sine and cosine are cofunctions. They are complementary. Tan and cotan are complementary also. They are cofunctions. Secant and cosecant are cofunctions. And then only cosine and secant, which are the reciprocal of each other, are even functions. The rest of them are odd. So if you just remember these, you will be fine. All right, let's solve a problem. So I think it's helpful to kind of get it organized. Okay, in case of kind of jingling all the way, just take care of each part separately. There are two parts here, what is given and then what we are looking for, what we are finding. So first of all, simplify what we are finding so that way you know what you're looking for. Okay, so we know that the cosecant, our rule has pi over 2 minus theta. But here you have theta minus pi over 2. So we want to first of all make it look like the formula. So we factor out the -1. So if we factor out -1, that would make theta negative. And then make pi over 2 positive. Okay. And then simplify that. Put the negative pi. Then pi over 2 will become positive. Use commutative property to switch those two around. Okay, so what we have now is secant negative theta. And again, this is like, it's like you have secant negative x. So we look at the even odd identity. We see secant negative x is going to be the same as secant positive x because secant is the reciprocal of cosecant. Cosine, like we see here, they are the two even functions. So we have negative secant, it's going to give you positive secant. So with that, we know that this is going to be, this whole expression here is like negative. Remember that pi minus theta is just one angle, is one angle. So it's saying that this angle is negative. So it's going to be the same thing as positive secant pi over 2 minus theta because it is even. But the positive of it and the negative of it gives the same thing. So therefore, we know that this thing we are looking for is equivalent to that. So we are looking for this. We are find that. Okay, and then we come to the left part. We start from what is given and then keep working with it until it looks like this one. So again, we look at, we have cosecant negative theta. Well, cosecant is odd function. So cosecant negative theta will give negative cosecant theta. Okay, the negative of it will give a negative y for the data. So which will be, we keep the right side as it is. Okay, and then we think cosecant and secant are cofunctions. So we can go ahead and substitute that into cosecant theta. Again, because here secant theta is equal to cosecant base and cosecant x is equal to secant pi over 2 minus x. So we're going to bring down the negative and then substitute cosecant theta with secant pi over 2 minus theta. And then we keep the left side. The equation is still equal. We haven't changed. We are just substituting. So now we have negative cosecant pi over 2, pi minus theta equals that. Pi over 2 minus theta equals that. But we are asked to find secant. We are looking for just positive secant. Well, what can we do to make it positive? We multiply both sides by negative or divide both sides by negative, and that will remove negative and both sides will become positive. So this will just become 0.75, and that's what we are looking for. Okay. So why not pause the video and try this one for yourself first of all, and then you check your answer. Alright, so we simplify the right side, what we are finding, and this negative x or negative angle, and cotangent is odd, so it's going to come out to be negative cotangent, and then we look at tan. Tangent is also odd, so it's going to tan. Negative theta is going to be negative tan theta, and so we know that tan and cotan are cofunctions, so they are cofunctions. So we substitute, we keep the negative and substitute that tan and cotan cofunction and still set it equal to, and it happens that this is negative cotan, which is what we are looking for. This is negative cotan, and so we keep it. We are done.